So we have 200 milligram. 200 milligram, okay, is dissolved in 100 cubic centimeter of water. That means now volume of 200 milligram is dissolved in 100 cubic centimeter, which is KMnO4. 15 cubic centimeter of 0.02 mole per decimeter cube oxalate solution is consumed to titrate 25 cubic centimeter of above solution. Look at that. In the above solution, now we prepared a 100 cubic centimeter solution. No? In that they are taking 25 cubic centimeter only. And titrating it with 15 cubic centimeter oxalate. Okay. Now you have to find the mass percentage of KMnO4 present in the above KMnO4 sample. Before approaching to the any calculation question, okay, you just have to make a plan how you are going to work this out. Now first what we have to do is first we'll write the only reaction happening is here MnO4 minus react with C2O4 2 minus. So MnO4 minus is reducing to Mn2 plus. Already the products are given. So they have make your work more easier. C2O4 2 minus will oxidize to CO2. First thing is you balance this reaction. Okay. So here oxidation number is plus 7. Plus 7 goes to plus 2. Here plus 6 is going for plus 8. Actually we have to make this 2 carbon dioxide. First step is you have to equalize the atoms on both sides. So this side 1 manganese, this side 1 manganese, no issues. But reactant side you have 2 carbon. So product side also you have to make 2 carbon first. That's the first step. Next step you have to say the change in the oxidation number. So plus 7 to plus 2 is minus 5. Plus 6 is going for plus 8, which is plus 2. Now what you have to do, you have to make this change in oxidation number same. So this plus 2 I am multiplying by 5, so it becomes 10. This 5 I multiply by 2, so it will become 10. So don't worry about the charge. You just have to make the number equal, okay? So 2 into 5 means C2O4 2 minus multiplied by 5. Carbon dioxide also we have to multiply by 5. So 2 carbon dioxide into 5 is 10 carbon dioxide. Manganese we multiply by 2. Next step is we have to balance the charges. So here you can see minus 2, 5 into minus 2, minus 10. So minus 12 is the charge in the reactant side. Product side 2 into plus 2, plus 4 charge. Now they say acidified. So this the medium is acidic. Then you have to add H pluses. Acidic medium means you have to add H pluses to the more negative side. So reactant side is the more negative side. Therefore, I will be putting 16 H plus. Then plus 16 and minus 12 is giving you plus 4. So both the side charges are equal. So I have to add 16 H plus. After balancing charge, the next step is you have to balance the oxygen. Reaction side, we have 2 fours are 8, 5 fours are 28. 28 oxygens are there in the reactant side. Product side, you have only 20. 10 times 2, 20. Then you need 8 more oxygen. 8 more oxygen means you have to put 8 water. 8 water. Final step, you check whether hydrogen is automatically balanced. Now this side you have 16 hydrogens. Product side also you can see here 8 times 2, 16 hydrogen in the bottom one. So the reaction is perfectly balanced. So any one of you having issues in balancing reactions? Are you okay with balancing equations? Okay. Sometimes you get them wrong, no? Okay. There's a particular order. So in the future questions, we will practice like how to balance. Now I will like try to finish this. So we'll take in a future class, we'll take a small time and like make your balancing more well. Okay. All right. So there are two methods to balance the equation. Now what I did was oxidation number based method. There is another method also, half firing method. So that is not much usually used. I mean, you have to know it. Sometimes they say to balance using that, but this is more convenient. Okay. So now I will move forward with this question. So here what happens is now this is the reaction taking place. Okay. Now this is balanced. Now what's the question? Find the mass percentage of KMN. You remember they dissolved 200 milligram sample. In that sample now I don't know how much of KMNO4 is there. Okay. So I have to find the mass of KMNO4. Then only I can find the mass percentage of KMNO4 in the sample. And also you have to remember our sample was in 100 cubic centimeter. But what we test is what? 25 cubic centimeter only. So first we will find the mass of KMNO4 in 25 cubic centimeter. Later we can find for 100 cubic centimeter. Okay. So now they have given the C2O4 2 minus volume and concentration reacted. So I can first find the moles of C2O4 2 minus. This is the plan I'm going to work out, okay? Then keeping the stoichiometry, I can find the moles of MnO4 minus reacted. So if I know the moles of MnO4 minus, I can find the mass of MnO4 minus. That means it is KMnO4, okay? Mass of KMnO4 I can find. But this mass you have to remember, this is for 25 cubic centimeter. But our sample is in 100 cubic centimeter. Therefore, mass of KMnO4 in 100 cubic centimeter, you have to multiply the above mass. You have to find the mass of KMnO4 in 100 cubic centimeter. After that, you can find the mass percentage as mass of KMnO4 over the total mass, which is 200 milligram into 100% will give you the mass percentage. Clear with the plan? So first always redox calculations you have to plan. After that you just have to substitute and go. Okay. Alright. So now quickly we'll solve it. Now I'm finding the moles of C2O4 2 minus. Now moles is equal to concentration into volume. Okay. So you should not forget this equation. To find moles you have two equations. One is concentration into volume. Other one is mass over molar mass. Now here you can use concentration into volume. 0.02 concentration. Volume you have to take in decimeter cube, but they have given in centimeter cube. So centimeter cube to decimeter cube also I convert. Here also you have to substitute with units. Mole per decimeter cube into decimeter cube. So that is 0.02 into 15. That is 0.3. So moles of C2O4 2 minus is 0.3 into 10 to the power minus 3 moles. MnO4 minus, you can see the ratio is 2:5. That means moles of MnO4 minus will be 0.3 into 10 to the power minus 3 divided by 5 and multiply by 2. So that is ratios, okay? That means 5:2 ratio, no? So that way I can take it. So that is 0.12 into 10 to the power minus 3. Now this is of course correct maths you have to follow. So moles of MnO4 minus is 0.12 into 10 to the power minus 3. Mass. Now you know mass equation you know, right? Moles into molar mass. Now molar mass of Km, now moles of KMnO4 is 0.12 into 10 to the power minus 3 into the molar mass of KNO4. Now we have to add and take. Potassium 39, 1 manganese 55, and you have 4 oxygens. Then it is 64. 158 is the molar mass of KNO4. You guys also just check it out with me. You have to do this. Gram per mole, mole. 158, I hope it's correct. 39, 55, 64, 18, 1 balance, 11, 14, 15. Yeah, 158. So that is 18.96 into 10 to the power minus 3 grams. So if I convert this to milligram, I can multiply by 10 to the power 3, then I will get 8.96, 18.96 milligram. Okay. 18.96 milligram is in 25 cubic centimeter. Okay, but our solution is there in 100 cubic centimeter because the entire thing we dissolve in 100. Therefore, in 100 cubic centimeter, you will have 4 times of it. 8.96 into 4 times. 18.96. That is 75.84 milligrams. That means out of 200 milligram, 75.84 is potassium permanganate. Out of 200 milligrams, 75.84 is that. Now you can take the percentage. 100 and here 2. 75.84 you have to divide by 2, then you will get the percentage. 37.92 percentage. Understood? This is actually a simple one compared to the past papers. Past papers one is a bit complex, but the thing is you have to nicely picture like what's happening. If you can draw a diagram and picture, then if you after you can put the plan, and after that after planning it's very easy. It's about your speed in doing the calculation. You have to be very fast in calculation also. Otherwise, for chemistry you will find very difficult to complete the paper on time. So that is why I am also giving very limited time so that you will be keep improving. So all clear with today's paper discussion. After the class, I will check your answers personally and tell your mistakes. For now, you have to correct your mistakes. Any doubts means you can ask now, otherwise I'll proceed with energetics revision. Okay. Now, energetics, I dropped the enthalpy definition video. I hope you would have watched it. Now, what we have to revise is mostly the calculation. Before that, from enthalpy definition and I mean from energetics lesson, what we have revised so far, we can answer a paper. I mean, answer few past paper questions. Okay. Mm. Okay. Can you see this two MCQs? So here you have a statement type MCQ and another MCQ. So these two MCQs I want you to answer and put the answer in chat box. When meeting ends, again come back with the first link, okay? Can hear me clear, right? Okay. Energy of a gas in a closed, rigid container with thermally insulated walls remain constant. Now, when we are talking about energy of a gas, gases are having only one type of energy, which is kinetic energy. So that also mean kinetic energy we know that is equal to 3RT divided by 2. Mean kinetic energy is depending only on the absolute temperature. So here they say thermally insulated, no? That means obviously energy cannot be exchanged and temperature will not change, no? As long as the temperature is changed, as long as the temperature is constant, energy of the gas is always remaining constant because gases have only kinetic energy and kinetic energy depend only on absolute temperature. So if I can take first statement correct, both energy and matter of an isolated system do not exchange with the surrounding. Now, when you take in this, they say it's closed rigid. Then matter cannot be exchanged. Thermally insulated. Then energy also cannot be exchanged. Therefore, this is like an isolated system only. Okay. Therefore, this second statement is anyway correct. No. Now, you both statements are correct. The thing is now you have to decide whether it is the first one or second, explaining or not. But we can take this as the explanation. Okay, because they say it's closed rigid container, matter cannot be exchanged, thermally insulated. So energy is like constant, it cannot be also exchanged. Therefore, here we can take as the answer 1. So, statement question. If both statements are correct and explaining means first option, not explaining means second option. Okay. 19th one, the correct reaction relevant to the standard enthalpy of hydration. Hydration is when an iron, okay, when an iron in the gaseous state is dissolved in water to form a aqueous solution of 1 mole per decimeter cube. Okay. So according to that, if you take, it should be a iron. So second one we can't take. Not OH minuses are not involved. Cl minuses are not involved because they are asking hydration of sodium ion. So the correct answer is third one. Sodium plus gas with water liquid is giving you sodium plus aqueous. When it comes to energetics, the physical state of the reactants is must. You have to carefully look to them. So I hope then that's clear. So now in the energetics, what we have to revise is the calculation. Okay, now lot of reactions we studied: hydration, solvation, dissolution, evaporation, fusion, sublimation. Likewise, around 14 are there. Enthalpy definitions are there. Those are all reactions actually. So when those reactions are happening, energy will be released or energy will be gained. That energy we can calculate. So that is what we do in the energetics calculation. Okay, we are going to calculate that energy. So there are a lot of methods where we can follow to calculate that energy, and all methods you have to study. Okay. So based on the given data only, you will decide which method to follow. So one by one we will revise. So first one, what I am going to do is enthalpy calculation when bond enthalpies are given. So you will find certain questions. I'll go with the example itself. That's easy. And I'll give you like 2 to 3 for you to try. Okay. So after this, after the calculation revision is done, we will be doing energetics past paper questions from 2020 to 2024. So before 2020, it's your responsibility to to do and complete. Okay. Okay. So I will take a reaction. C2H2 is reacting with hydrogen. I am writing the balanced reaction, giving C2H6. So when bond enthalpies are given, it's the must that you should have an idea on the Lewis structure. So we will draw the Lewis structure for each compound. Because this bond enthalpies, each bond energies only will be given for you. 2 carbons and 6 hydrogens. Okay. So the equation for this is, if you want to find the enthalpy change. Now enthalpy change symbol you know, delta H naught. Okay, this is standard. When you put the note mark, it is standard. Okay. Standard enthalpy change of this particular reaction if you are finding from bond enthalpy. Okay. That is equal to enthalpy change of broken bonds. The broken bonds you have to add the enthalpy of broken bonds and subtract it with the enthalpy of the formed bonds. Now you have to identify what are the broken bonds. The reactants are there, no? Their bonds only will be broken because you can see now C2H2 is reacting with H2 and forming C2H6. So all these bonds are broken actually, and a new bonds have been formed as C2H6. So the broken bonds are the reactant bonds. Okay. The formed bonds are the product bonds. Okay. So they have given the data. Now I'll just give small data. Okay. Now you can see, now you have to identify all the different types of bonds. So you can see hydrogen carbon single bonds are there. Carbon carbon triple bond is there. Hydrogen hydrogen bond is there. So these are the 3 different types of bonds present in the compounds. And all of their bond energies will be given. Now let's say hydrogen carbon is 100. I'm just putting, okay, not the real values. Carbon carbon I'll take 200. Hydrogen hydrogen I'll take 150. Now you know energy. The unit is kilojoule per mole. Per mole only we take. Energy is anyway joule, no? I'm taking kilojoules and that is also per mole. That means per mole of bond. Okay. Now you have to, now this is the equation. This is the first equation. So delta H is equal to H naught broken bonds. Now I said broken bonds are but the reactant bonds are only broken. Now in the reactant you can see the carbon hydrogen bond you have how many? 1 and 2. 2 carbon hydrogen bonds, 1 carbon carbon triple bond and hydrogen bond how many you have? 2 because you have 2 hydrogens. So these are all the bonds being broken. So all of their bond enthalpies you have to add. Now carbon hydrogen I will take. Now carbon hydrogen and it is 100 kilojoule per mole. I have 2 carbon hydrogen bonds. Therefore 100 into 2. This also you have to put the unit kilojoule per mole. I am not putting. Then you have carbon carbon triple bond 1 that is 200. Hydrogen hydrogen that bond we have 2. Then 150 into 2 which is 300. So these are all the enthalpies we have added for the broken bonds minus the formed bonds. You can see formed how many? Carbon carbon single bond have been formed. No? So that also we need the data. So carbon carbon single bond I will take 100. No, 120. So we have one carbon carbon single bond. So I'll take it 120. And you can see carbon hydrogen bonds. There's 1, 2, 3, 4, 5, 6. That means carbon hydrogen bonds 100 into 6. No? Now the rest is calculation, doing it properly. 200, 200, 400, 300, 700. 700 minus 600 plus 120, it is 720. So 700 minus 720 is minus 20. So the enthalpy change of this reaction is minus 20 kilojoule per mole. So this minus sign is indicating that this reaction is exothermic. So understood how to use this bond enthalpy? Okay, now quickly take a note on this. Now this also you will decide. Now if they have given data like this, now I have given a set of data now. Hydrogen like this, if they give the data, then you have to use this method to find the enthalpy change of the particular reaction. So based on the given data only, you will decide which method you are following. So quickly take a note on this and tell me. I'll give you one to try. So in this case, you have to be very careful with the stoichiometry. Okay, now 2 hydrogen means you have to multiply by 2. Sometimes it can be half also. So then you have to multiply by half. Likewise, you have to be very careful with the stoichiometry. Other than that, you can manage this. When you're done copying, tell me. Okay. So now I'll give you one to try. We can go directly for the past papers. That's the PDF. Okay. Mm. So this PDF contains all the energetic questions from 2020-24. So whatever we can, we will do. Okay. So I want you to do this 12th one. This is from 2024. Yes, you can do that. Put the answer in the chat box. Okay, so both of you says the same answer. Quickly, let's check it. So we can see hydrogen bond half. That is 436 into half plus 242 into half minus 1 HCl bond of 431. So that to it 218 plus 121. 339 minus 431. Yes, minus 92 kilojoule per mole. Good. So using same bond enthalpy, they have given a different approach. Now look at this 18th question. This is 2023. Okay. So they have given a reaction. So see the same reaction by halving it only they gave in 2024. No. Okay. So H2 and Cl2 reacts and form HCl gas. Okay. So you have to find the enthalpy change of this reaction. So all the data has been given. Okay. And you have to find the correct energy profile diagram. Now in O levels also you have drew these energy profile diagrams. You know that. Now you will get an idea like once you find the enthalpy change only you can determine. Where once you find the enthalpy change you can determine whether it is endothermic or exothermic and you can pick the correct diagram. Start this now. And you should also have the idea that endothermic means products have greater energy than reactants. Exothermic means reactants are having greater energy than product. That point also you should keep in mind when finding the answer. Model. Okay, let's see different answers, both of you. Okay. So H first I'll find the enthalpy change. H2, now you can see one hydrogen bond, then 430 plus ClCl bond 1, 240 minus you can see two HCl bonds. Then 430 into 2 means 860. 670 minus 860 is giving you 0. 16, 7 goes 9. 190 minus 190 kilojoule per mole. That means enthalpy change should be 190. Then all 240, 240, 380 you can cancel. Now you have to see whether the answer is 1 or 4. It's an exothermic reaction. Exothermic reaction, reactants are having more energy than products. Now you can see this y-axis is energy, no? Therefore, see the reactants H2Cl2, they have greater energy than HCl. When you see that here. First one is the correct answer. Okay. So broken bonds minus formed bonds. Okay, then clear with that. So this method you have to follow only when the bond energies of the uh, compounds are given. Okay. Now we can also learn another one step by this. Formation enthalpy. So now let's learn the second. Now there's another reaction where we can equation where we can use to calculate the enthalpy change of reaction. That is first I'll write the equation, sorry. Standard enthalpy change is equal to standard delta HF. Delta HF means enthalpy of formation of products minus delta HF reactants. Can you all see the screen? Okay. So here what they will give as the data is the formation enthalpy of the each compound in the reactor. The reaction. Okay, so I'll take a reaction. Example. Mm. So I'm writing the balanced reaction. For ammonia is reacting with 5 oxygen and giving us 4 NO and 6 water molecules. So this is the reaction. And what they have given is data is formation enthalpy. Now you know there is a enthalpy definition of formation enthalpy. So formation of ammonia minus 420. Formation of water minus 200. And formation of NO gas plus 40. Now we know that when you have elements in the standard state, can you see oxygen? Elements in the standard state. When you have elements in the standard state, their enthalpy of formation is 0. Okay, therefore they have given the formation enthalpy for ammonia, NO and water. Now we will put to the equation. So delta H naught is equal. Now you have to add, first one is what delta HF products. That means you have to take the sum of the formation enthalpy of the products. Products is NO and water. You have 4 NO, that means NO it is 40, no? 40 into 4. You also have to substitute with the unit. I am not putting the unit, but you have to substitute with unit. Water it is 6, that means minus 200 into 6. Because they have here given for 1 mole only. Okay. So you have to multiply it with the stoichiometry. So these are the sum of the formation enthalpy of the products minus sum of the formation enthalpy of the reactant. So in the reactant we have only ammonia because oxygen 0. Ammonia 420, no, minus 420. And you have 4 ammonia. So here 160 minus 1200 minus 0860. 1200, 160 goes, it is minus 1040. Minus into minus plus 1680. Then final answer will be a positive one, 640 kilojoule per mole. Positive means endothermic reaction. Understood how to work out if formation enthalpies are given? Okay, now copy it. Now here the data is formation enthalpy means you have to use this method. If bond enthalpies are given, we have to use the previous method. If formation enthalpies are given, you can use this method. So copy and tell me. Okay. So we can do one more question in based on formation enthalpy. Based on formation enthalpy. Yeah, you can do this one, this Roman number 1. Okay. So they have given the formation enthalpy of NO. Also the formation enthalpy of NO2 here. Yes. Work out the formation enthalpy for this reaction. 2NO plus O2 giving you 2NO2. Okay, both of you have got the same answer. Let's see. Products NO2, no. 33 into 2, it is 66 minus 180. It is 0, 4. Wait. Minus 114, no? Yes, correct. Exothermic reaction. Okay. So are you clear with today's session? So we have only like two more calculations to revise. I mean, we have a thermochemical cycle, thermochemical equation, then enthalpy level diagram, and also entropy and Gibbs free energy. That is actually coming with one equation. But now we are studying these methods, right? We'll be studying a thermochemical cycle, thermochemical equation method to calculate the enthalpy change of reactions. So the future ones we can use not only for enthalpy, for delta G, for delta S also we can use. So we'll continue in the next class. Okay. So I will look at your answers after the class and tell you how you have to improve. Okay. Okay, then thank you for joining. Good night. Thank you.